Okay, this lesson is going to be over 9 for rational exponents. So let's think about what a rational exponent is. So exponent means I have a little number raised, given a base. And a rational, when you think of a rational number means a fraction. So for instance, if I have some number raised to the exponent that is a fraction, so let's say m over n, because we're not quite sure what those numbers are. The numerator, there's a variety of ways of how I could write this. Yes, I could write it as an exponent, but I could also write it as a root. Well, how do I know what the numerator and the denominator of my exponent are in regards to my root? Well, the numerator is always the exponent part. Exponent. So another way of writing this would be root of a raised to the mth, and the denominator is actually going to be the root part. So because this is the nth root, I would put a little n on the outside. And the order does not matter. So a raised to the m over n could be rewritten as the nth root of a to the m. Or you could actually take also the root part first. I could take the nth root of a and then raise that to the mth power. So order does not matter, but I can rewrite a fraction exponent using a root or using a radical. So some common rational exponents, if we come over here on the side, x to the 1/2, as a reminder, is just square root x, because 2 denominator is just a root of 2, so square root. X to the 1/3 would give you a root of cube root x. And if we had a numerator not of 1, x to the 2/3 would be the same as the denominator is the root cube root of x squared. So it's just a reminder. Now, with exponents, we have different properties or different laws of exponents that we follow. So let's refresh your memory on some laws of exponents. Okay, what are some general laws or rules that we can follow regarding an exponent? So let's say, for instance, I have some number raised to an exponent, and I'm going to multiply by that same base raised to a different exponent. Well, when I have two bases, two exponents, and I'm multiplying, well, since I have the same base, and you can only do this if you have the same base, you can keep the same base, and we can add those exponents. So two bases, two exponents, we can add the exponents. We do not add the base, though. Base stays the same. Well, what if I don't have two bases? What if I have the entire base and exponent? All of that raised to another exponent. So we have one base, two exponents. Well, one base, two exponents means we multiply. So you'd have just a to the mth, all of that raised to the nth would equal a to the m times n. Well, what if we have two numbers multiplied? And then on the outside raised to another exponent. Well, here I just can distribute that exponent to each base. So this would be a to the m times b to the m. Likewise, what if we have a fraction? A divided by b. Again, raised to the m power. Whether it's multiplying or dividing, I can distribute that exponent. So this would be a to the m over b to the m. Oh, I guess I should color code. This should be m. This should be m. Okay, a few others. What about negative? So what about here? We have two bases and we have two exponents and we're multiplying. So what about if we are dividing? So what if we have a raised to some number over, again, that same base raised to a different number? Well, how can I simplify that? If I have the same base with division, then I can subtract my exponents. And last but not least, what do I do when I have a negative exponent? Well, if I have a negative exponent, to make it positive, all you have to do is put it 1 over. So send it to the denominator. So if it's a negative exponent in the numerator, send it to the denominator. If a negative exponent is in the denominator, you're going to send it to the numerator. Okay. So that is a refresher of some laws of exponents that are going to help us simplify some rational expressions today. Let's look at some examples. So let's start with the first example 1. So what if we have 11 raised to the 1/2 times 11 raised to the 1/2? Well, we have 11, base of 11, base of 11, same base, two exponents. So our laws of exponents tells us we can add our two exponents. So what is a half plus a half? A half plus a half is a whole, or think of it this way. We have two fractions. The denominators are the same, right? So we add the numerators and we keep the denominator the same. So 2 divided by 2 is 1. So 11 to the first power is just 11. And we're done. So what about this one? What if we have 5 to the raised to the 1/4 power times 125 raised to the 1/3 power? Well, I'm kind of stuck here. Okay, 5 raised to the 1/4. I don't know how to simplify that. 125 raised to the 1/3. Not quite sure about that. So why don't let's look at 125 though. That's kind of large, and I'm raising it to the 1/3 power. So let's see, is there a different way I could write that? Okay, and there is. As we talked about with roots, okay, a denominator is actually the root part. So this is really the same thing as saying the cube root of 125. Ding, ding, ding. What is the cube root of 125? That's a perfect cube. Cube root of 125 is 5. So really here we have 5. Really here we have 5 1/4. So you got to get my pen working. 5 1/4 times 5 to the first times 5. Well, I have a base of 5 and a base of 5. What can I do with those two exponents? I can add those two exponents. Well, notice right here, I don't have an exponent. I really only have 5. Well, this is really 5 to the first power. Well, if I need to add that with a 4th, I need to get a common denominator. So if this is denominator 4, do we not agree that 1 is the same thing as 4 over 4? I think that's the same thing. Why do we want to write it out like that? Well, now I have base of 5, base of 5. I can add my exponents. So this would be 1 plus 4 all over denominator 4. So 4 plus 1 is going to be 5. And denominator stays the same. So 5 raised to the 5 over 4 is how we can simplify 5 raised to the 1/4 times 125 raised to the 1/3. Let's try another one. What if we have square root 7 times the cube root 7? We got a square root and a cube root. Kind of stuck, and 7's prime, right? We can't take the square root. We can't take the cube root. So let's try to rewrite it as a fraction. So square root of 7 is the same as saying 7 raised to the 1/2. Cube root of 7 is the same as saying 7 raised to the 1/3. Well, now that I write it as an exponent, I can use our laws of exponents. Well, two bases, base is 7, base is 7. What can I do with the exponents? I can add the exponents. So what is 1/2 plus 1/3? Well, here we got to get common denominator. So since I need to get a common denominator of 3 and 2, that's going to be 6. So here I need to multiply the top by 3. And here I need to multiply the top by 2. So now that we add our numerators, 3 plus 2 is 5. And our denominator stays the same. So 7 raised to the 5 over 6. Or if you want to write it as a root, this would be the 6th root of 7 to the 5th. So not too bad. So let's take it up a notch. So what if we have 8x to the 15th power, all of that raised to the negative 1/3? 8x to the 15th, all of that raised to the negative 1/3. Well, here I like to start by making things positive. So notice I have a negative exponent. It's raised to the negative 1/3. Well, since it's raised to the negative 1/3, how do I make it positive? I can boot that to the denominator. So using our law that says I can create a positive exponent, I'm going to put 1 over 8x to the 15th and then all of that to the 1/3. To the positive 1/3, because if I boot it to the denominator, it becomes a positive. So if you need to write out steps, okay, we're moving to denominator to make positive. Move to denominator. To make positive. Okay, now we can distribute this 1/3. Now we can distribute this 1/3. So I have 1 over, this is really 8 to the 1/3 times x to the 15th to the 1/3. And 8 raised to the 1/3 is the same thing as saying cube root of 8. And ding, 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 8 is a perfect cube. We'll simplify that here in a minute. 15 times 1/3 will give us x to the 5th power. And now all we have left to do is simplify the cube root of 8. So 8 is a perfect cube. Cube root of 8 is 2. And we had the 2 is times x to the 5th. So 8x to the 15th, all of that raised to the negative 1/3 can be simplified all the way down to 1 over 2x to the 5th. Not too bad. Let's take it up another notch. And what if we have 9x to the 4th root, y, to the 3/2? So how are we going to simplify this one? So I would start by distributing our exponent. So let's take this 3/2, and I'm going to take 9 and raise it to the 3/2. I'm going to take the x and raise it to the 3/2. And I'm going to rewrite y to the 4th, because the 4th root of y is the same as y to the 1/4. And then I'm going to distribute the 3/2 to that. Ooh, my mouse keeps moving. Okay, so let's see what we can simplify. Let's start with the easy part. Here we have a fraction times a fraction. So how do we multiply fractions? Top times top, bottom times bottom. So 1 times 3 is 3. 4 times 2 is 8. Now 9 raised to the 3/2. Remember that the denominator is the root. So if this is over 2, that means I really have square root 9 and then cubed. And x to the 3/2 we can just keep as x to the 3/2 for right now. So let's simplify. Well, I can do the root or the cube part first. So what's the square root of 9? Square root of 9 is 3. So this is really 3 cubed. X to the 3 halves, y to the 3 eighths. And what is 3 cubed? 3 cubed is 27. So final answer, 27, x raised to the 3 halves times y to the 3 eighths. So one last one. Taking it up our final notch. How are we going to simplify x raised to the negative 11 over 10? So again, I always like to start by making positive. So we're going to send it to the denominator to have 1 over x raised to the 11 over 10. And now we can actually make this smaller. So let's think about what a rational exponent means. It means I really have a root, and the denominator is the root. So if the denominator is the root, that means I have a 10th root of x to the 11th. Now, since my exponent is larger than my root, this means that I can take some of it out. So I'm going to rewrite this, okay? So I have the 10th root, and do we agree that x to the 11th is x to the 10th times x? It's the same thing, right? 10 to x to the 10th times x is x to the 11th. I'm just writing it a little differently. Now, why do I want to write it differently? Well, what is the 10th root of x to the 10th? Well, that is just x, so that can go on the outside. And then I only have 1x on the inside. So x raised to the negative 11 over 10, I can simplify as 1 divided by x times the 10th root of x. And that completes our lesson on rational exponents on 9.4.